Hello guys, welcome back. This is part 2 of Mastercam 2022, making a part program from wireframe to solid. So let's get started. So in the first video I made a wireframe and then I converted it into a solid, basically a paper to print format. Now I'm going to generate some toolpaths onto this part. So now what I will be doing is I will simply go to machine. I can bring in the mill because I can see it is a milling part. Default, we can see properties and other structures. And now what we are going to do is click on file. I'm going to randomly name it as 111 from material because it's better to justify the material and so that Mastercam already brings up few of the feed and speeds for you rather than you bringing it in. If you know the feed and speeds, then go for it. Click all these. We are not going to select the fourth one. Clearance height, retract height, feed plane, material. I will just go with 6061 right here, and then stock setup. Stock setup, either you can select with bounding box. I can simply select right here, click OK. You can see it's going to generate 3 inches, 4 inches and 1 inches, so it already picked up all the points. I can add some extra. I would add plus, or I can simply say okay, instead of 3 I'm going to add 1/8 on each side, so 0.25, so it will be 4.25. and on the thickness on the z-axis I will add 1.25. there we go. On x I'm going to leave 0 0. On z 20 thou just for the facing, and display and click OK. So we have the red marking as the raw stock material that we are going to be working with. So you can also see when I go on the front plane, I've left about 20 thou for the facing operation so that I can chip that off. So the first operation that I'm going to use is face. I click on face. I don't need to select anything. I simply click OK. Click on tool, and we will use the face mill which we already have right here. Click OK. 3-inch face mill. You can see that if you have a tool list, follow the tool list, whichever it. You might have 3-inch or 4-inch of face mill. Generally 2 to 3 inches standard. Feed rate, you can according to tool list, follow the tool list. I'm just following a few numbers that I know from top of my head. Cutting method, one way could be zigzag or one pass if the tool diameter is bigger than the cutting part. So in this case I think it is 3 inches, so I think it's going to show an error. Better to have zigzag. Approach distance 50-50%. You can keep it 25 if you want to, not that big of a deal. Step over, I would rather keep 50%. Stock to leave on floor should be 0. We don't want to keep any material. Depth of cut, you can turn it on, not an issue. Step down, keep tool down, it's just one pass anyways. Linking parameters, clearance, I just like to keep all of them in absolute because it makes my life easier. Top of stock in this case is going to be 20 because we left 20 thou for the facing. Feed plane is generally 100 thou above the top of stock, so it will be 0.12. and retract value you can keep slightly higher than the feed plane, about 100 thou, which is already very close to it, so I'm just going to leave it at 0.25. I'm going to use clearance at the start and the end of the operation, just for the fact that I don't want to spend too much of time moving from one operation to the other operation if there are multiple variations of it. So all in absolute, top of stock, everything looks good. Come to plane, these are two front because I just, in in order to show you guys that 20th stock material above the origin, it automatically chose front, so make sure all of them are on top. Turn on the coolant, do not forget that. Everything else is going to be good. There we go, you have the first operation made, that is facing. Now this for the second operation, we can go for it. I'll just make all the operations first and then verify at the very end. If you want to verify, just use backlot. You can just use backplot and see that okay, how it's actually going to cut, and you can see zigzag motion and it cuts really good. So what I'm going to do is now make sure that I will get rid of the excess material around it. So I'm going to use contour for that. The wireframe, I will be using the wireframe. Click OK. Make sure the chain is pointing outwards. Okay, I'm going to use half inch bull. Sure, why not? With 1/8 radius, you can keep the feet to be around 24. Spindle speeds around 4000. Well, they are very close to what they should be kept. So they all Mastercam is already giving you an idea what the spindle speed and feet should be. Cutting parameters, stock to leave on wall, I'm going to keep it 10 thou, just for the fact that okay, I want to make sure that I have some material left for the finishing parts. Depth of cut, uh, well, in this scenario I need to make sure depth of cut is half of the tool diameter. So tool I'm using right now is half an inch, so 0.25 is really good. Lead in, lead out, I'm going to turn off that enter at the midpoint and make sure that I have my lead in and lead out at 25% each for both entry and exit, and I'm going to overlap about 100 thou just to avoid any mark on the part itself. So breakthrough, no. Multipass, not for only for the finishing pass. Going to make sure all of them are in absolute. The depth is not visible for this one. For the contour, is just taking in through all for some reason. That's weird. So I'm going to specify the top of stock, which is going to be 0 in this case, and then feed plane is the same, or you can make it 100 thou, not that big of a deal. Depth you can specify to be the end of the stock right there. It's very weird, it's not picking up, but we know that we can put in the value if we want to, -1. If you want, you can also break through it, break through by 100 thou, 0.1. Then make sure coolant on, and all the planes should be top. Oh yeah, that's why. Now I see. That makes sense now, because the planes were top, front and front, that's why the linking parameter were messed up. So now we have the depth. I can simply click on it. There we go. It already picked up the point. Coolant, turn it on, click OK. Now you can see that it is selecting the inside. Right click, change side. You can see the arrow is pointing outwards. That's what we want. When we click OK, regenerate it, you can see now it's cutting correctly. It is really important to make sure the wireframe and the selected toolpath are in right directions and the arrow is pointing outwards, because you want to be cutting the outer material, not the inside of the wireframe. So it looks good so far, so good, but we still have 10 thou material left on the side, so we need to get rid of that. What I'm going to do is I'm just going to copy this and paste it. Make sure the red arrow is underneath it, copy and paste it. The wireframe is going to be same. I'm just going to just click on parameters and make sure I go to parameters, and the stock to leave should be 0. Depth of cut, I'm going to just turn it off, because I just want the tool to go deep to the depth. on the very first pass and just cut off the 10 tau that is left behind. Lead in, lead out, all the other parameters are going to be the same. Breakthrough is going to be same. Multi-pass, if you want, you can turn it on just for the finishing side to have multiple passes depending on your personal needs. You really don't need to, but it's better to have a better finish. So it says that for rough, which we already did, we don't need to. We can keep it 0. For finish, if you want, you can keep like 2 passes, spacing of I mean, let's say, because five uh, only 10 tau is left, so for spacing of 5 tau you can say. And Lincoln parameters are going to be the same, exactly the same. Everything else is going to be exactly the same. Click OK. Then you can see that okay, you can verify how it's working. It's cutting the material and the second tau. So 2 cuts, 5 tau each, chopping of 10 tau at the very end, which is a good finish. So we have made the outer boundaries perfect according to our needs. Now what we need is to make sure that we make drills and also this pocket and the inner pocket as well. That is really important. So we have one operation that is the facing, the other two are contours. So now it's time for drill. So for drilling, you click on drill right here. When you control and left click on the hole itself, it's automatically going to select all the holes. That's one of the feature that I've seen that is really good in order to have multiple selections rather than selecting it individually. You can also select the order. You can click on which order do you want to be selected in. So I want the drill to come in to the first one, then to the second one, third and fourth one, which I think is really good. So this is the formation that I'm looking for. I will click OK. I will go to tool, and right here I know that whatever the thickness is, if I'm not sure, you can also use analyze entities or analyze entity properties right here, and you can see that okay, the diameter is 0.25 and the radius is 0.125, so we can use that. Select tool. First of all, we are going to do center drill, so I'm going to use center drill of 0.5 diameter. Center drill is basically just for centering, or you can say you can also use a pilot drill to make sure that the alignment of the drill is straight, or the hole is straight. It's basically perpendicular to the part. That's what it's used for. Feed rate of 14. I'm slightly not sure the feed rates of drills, what they should be. I will just go with 30 for now, and spindle speed of 3000, and then everything else looks good, nothing much special. Lincoln parameters we can check right here. I'm going to keep all the absolute value. The depth I'm going to keep here is going to be negative 0.25 because I just want a little bit tip to be hitting in so that I have a marking on it to start with. To retract values 0.1, 100 thou over the top of the stock because we have already done facing and we have material left. And I'm going to keep the drill to be the same, around 2 inches above the stock. We can also check the collisions here. Oh, I see. We haven't specified the tool yet. Okay, not an issue. The tool here is 16 inch. Oh, 0.5 inches. Okay, half an inch. We don't want that for sure. 0.5 inch drill. Yeah, I mean, it looks fine. Linking parameters are good. 0.25 depth. Okay, tip compensation planes. Oh, I see. Front, top, and top. Now let's go and verify it. Check collisions. Alrighty. Unreachable shoulder, everything looks good. I never use this. This is my first time using it, so I'm just checking out what exactly is this feature capable of doing it. Okay, tool opacity. Alright. Okay, makes sense. Reachability, unreachability, shoulder. Okay, shank, shoulder, preview opacity. Okay, not an issue. Okay, that looks fine. Yep, that looks beautiful. Click OK. There's no collision from my understanding. Turn on the coolant. Make sure that's important. Click OK. There we go. You can see it's counter bore, basically drill counter bore. I think it might have given a chamfer as well. We can verify that. Yeah, there we go. You can see I'm just letting go slightly to the depth, not way too much. You can also reduce if you want. That's not that big of a deal. If I just want to verify that particular operation, that's what I'm going to do right now. Let's see how that works. There we go. Verify once again, and there we go. I'm going to turn the stop collision. Collision should be on. Everything else looks fine. And you can see, yeah, I mean, it just looks a little bit too much just for the fact it's not phased. I think it's good for now. We are going to use the drill, the proper size drill now. That's really important. We have verified it's 0.25 in diameter, 0.125 in radius. So what I will do is I'm just going to copy and paste the same operation. Copy and paste. Geometry is the same, everything is the same. I'm just going to change the tool itself. I will go to tool, I will go to none, choose drill, and the size should be equal to 0.25 in diameter. So 1/4 drill, this is the one that we are going to use. Drill feeds and speeds, not sure, not gonna change, not gonna mess with it. Holder and everything looks good. Toolpath is good. Lincoln parameters going to keep the same. The depth will be different because it's through all. And also going to tip compensation, I'm going to increase breakthrough amount to be 100th as well. Or what you can do is you can simply go here and say that okay, just add whatever the thing is, whatever the depth is, so that you can turn off the tip compensation. You don't need to. Or if you already know that there is no feature underneath or on the back side of the part, you can simply just add whatever the break through all value you want to. So now everything is almost done. All of them are on top. Coolant should be on. Click OK. There we go. We have back drill through all 0.25. Now what I'm going to do is the next one. So we are done with the outer. We have done face. We have done contours. Then drill. Then back drill. Then now we are working towards the inside ones. So I can use two different methods. One is going to be pocket for the slot, and then the bigger one, the middle one, I can use the dynamic milling. For the center one, I'm going to use dynamic. The same machining region is going to be the center one. I'm already done with that right here, starting from here. And yeah, I will just make sure that I start from there. Preview chain overlaps itself. It says stay inside, avoidance reason, air reason, contamination reason. Okay, Alrighty, machining region is going to be inside of this run. Change side. Okay. From outside, no. Avoidance region it should be this one. PV chain is overlapping. Alright, not an issue. I'm not going to keep high speed. I will just simply use pocket if I want to. That's not that big of a deal. But let's try once again. So it's saying that automatic region should be this. Oh, my bad. Machining region. Oh, 3D. This one right here. PV chains overlap from outside. PV chain overlaps again. Automatic region. Oh, alrighty, not an issue. Click now. We'll go with simple tools then. First I'll make a pocket. This one right here. I will use bull and mill. Stock to leave on wall 0.01. Stock to leave on floor 0. Roughing. Step over. Alrighty. So constant overlap spiral entry motion to be 50%. You can keep it, yeah, 50 is fine for now. Finishing, not going to turn on finishing. Lead in, lead out should be kept away as well. Breakthrough, we can turn it on. 0.1. Linking parameters, clearance, all absolute values, just like I prefer. Top of stock is going to be this right here. Negative 0.75. I think the planes are messed up again. Front ones right here. Top planes, top of stock right here. 0. Depth is going to be all the way here. 0.1. 0.1 is going to be the top of the stock. Use clearance. Breakthrough value. Plane and coolant right here. Pocket, yes. I think it's showing some error because of the chains that I selected. Yeah. Delete. Add. I'm going to use the wireframe itself. That's fine. There we go. Yep. There we go. I'm going to see how it's working. Alrighty. Okay. That's a lot of plunging. That's a lot of plunging. That's a lot of plunging. It would be better if we can do dynamic mill. I don't know why it's showing error again and again. Area comment avoidance region. Should this one? I'm pretty sure about that. PV chain. Okay, not this one. Machining region should be this one as well. PV chains overlapping. Air region should be the one that should be the other side. Air region is a non-cutting region. Chains overlapping. Why so? That's very weird. Avoidance region is this one. Chains are overlapping. Avoidance. Oh, maybe because of the planes. Yeah. Keep everything in the top plane. Make sure. Isometric. Dynamic mill. Machining region is going to be this one right here. Yeah, there we go. That was the problem. The planes itself was the issue. Again, machining region. This time I'm going to choose solid. Start right here. Or before that, I think it's better to choose machining region to be at the top because we haven't machined this slot yet. I'll just go with all the best possible tools that we have. I'm going to use end mill. Approach distance is fine, 0. Alright, step over distance to 50% is good enough. Stock to leave on wall, I'm going to keep at 10 thou. Stock to leave on floor, 0, definitely. Depth of cut, okay. The requested step over exceeds the flat diameter. Step over, oh my bad. Wait a sec. Step over should be 100% instead of 100%. That's fine. Oh, this one. Step over. Okay, 25%. Alrighty. Depth of cut. Turn it on half of tool diameter. Good enough. Breakthrough. Nothing is there on the other side of it, so why not? Absolute all the way. Absolute. Top of stock should be 0. Feed plane according to it. This should be at end. -1. Plane should be all top. Coolant should be always on. Not a bad deal. Good enough. So we can get rid of this pocket, or what we can do is we can just change the wireframe and make sure that we cut off that extra material. So I'm going to rechain all and say that okay, instead of cutting that, I want to cut this region, and I will change, reverse the direction of it. There we go. There we go. So I'm just going to change some other parameters for the pocket as well. Just like linking parameters, top of stock is 0, depth is going to be right here, and there will be no breakthrough. Just cut the breakthrough right there. And also I have to make sure that I have some material left which I need to get removed of. So what I'm going to do is I'm going to copy this operation, the pocket operation, Control C, move my red cursor up and paste it right here, pocket, and I'm going to do the same thing. Remove stock 0. Make sure all the other parameters are good. Roughing is going to be finishing now. You're going to be using finishing. One finishing passes, you can keep whatever this thing is. 5 thou spacing for 2 passes, or even 10 thou if you want to, not an issue for 1 pass. Lead in, lead out, sure, why not? 25%, 25%. Same thing goes in 0.1, and yeah, depth of cut, you can simply turn it off because the entire material is gone. Nothing else to change. Yeah, nothing else to change, literally. Coolant is on, everything is good. Yes, so it looks good. So we are done with most of it. We got all of that material. We just have 10 thou left for this one, high speed finishing that we have. So I can now either choose to do a simple contour, which is not that big of a deal after whatever the material is left to cut. Choose the tool, half-inch pull, good enough. Cut parameters, stock to leave 0. Depth of cut, turn it off, it will go right to the depth. Breakthrough 1 thou. Okay, I mean it's good, it's all good. Top of stock should be 0. Depth should be -1 right here. Plane, top all of them. Coolant on, there we go. Change the side, you can see geometry is wrong. Change side, turn it on, good enough, and save for now. And let's select all the toolpaths and see how it works. I'm going to maximize the screen. Zoom out a bit, verify, color loop, just to differentiate. Performance I'm going to keep slightly high so it looks good. High speed machining, my friends, and you can see why do we have this material. Maybe it's just a precision itself. And yeah, don't worry about this material right here, it's just a little bit of stock material that is left. I can just add in a little bit of extra depth to all the parameters, but you can see that there is, because of the lead in and lead out, there is some issues right here. Which operation is that? The blue one right here. Alrighty, let me see. Let me verify it once. Okay, this is the side. Alrighty, let me verify individually. Everything looks good. Facing is good, counter is good. It must be one of these ones. I need to make sure. Okay, just verify this one. Oh, okay. Ah, that makes sense. Alright. Let me verify once again the parameters for this one. The standard tool is half-inch bull. Why not use half-inch flat indeed? Yep. Anyways, let's see. Top of stock. Roughing parameter constant. Parallel spiral. Let's see. Step over percentage should be 25. Entry motion. Okay, entry motion keep it 20% as well. Maximum radius, plunge, skip, feed rate, finishing. Alright, lead in, lead out. Depth of cut. This is for the roughing one, yeah. Good enough. Link in parameters. Good enough. Plane, good enough. I mean, everything looks fine. That's not that big of a deal. Doesn't look that big of a deal to me. Okay. It's cutting in the pocket, but it's cutting in a very different way though. Kind of slightly weird, but good enough. And this is the contour for that. Overlap value is slightly less because the tool is slightly bigger than what I expected. Roughing should be off, entry motion eventually off, spacing is fine. I can indeed have two of them. Lead in and lead out 25%, tangent, helix motion 0.2 if you want to, not an issue. 2.5 to be precise. Alright, and for the pocket, alright, finishing, roughing. I'm pretty sure the breakthrough is not on, because that's the one that must be keeping an issue. Keep tool down. For roughing, parallel spiraling, constant spiral or parallel spiraling. Alright, entry motion 20. Yeah, it's good enough. Right here, selecting only that operation for now and seeing what exactly it's going to do. Alrighty. Okay. I think it's just the quality of it, precision itself. Everything else looks good to me. Yeah. Everything else looks good to me. Precision is going to increase for a while. so that I know that. Okay. Huh. What is this separation right here having the issue? The blue one. Wait a second. Okay, this is the drills. Drills are fine. All drills look good. Then when it starts cutting this one. Okay. Very weird. The blue one. Which one is the blue one though? The blue one is the count 2, right? Right here. Oh, I see. Oh, I see now. Oh, okay. Okay, that makes sense. I will be deleting number 7 and I will be adding a count row to it. I'm going to copy number 8, move it right here, paste it right here, paste it right here, and change the geometry of it. Rechain all right here inside. Click OK. Parameters, tools right here. Bull and mill, everything looks good. Depth of cut should be turned off because that's for the finishing one. Everything else is good. Breakthrough should be off as well. Multipass, 2 of them for 5,000. Sure, why not? Depth, we are just going to keep this one because we are just going till there. 0, 0, 1. Good enough. Top of them. Coolant should be on. Good enough. Yes. I hope we cleared the issue now. Still having this. But yeah. It looks really good. It just, I think the fact is now I just need to make sure that there should be no breakthrough. That should be on. No breakthrough is on. Nothing is on. It's just parameters. Multipass is on. Breakthrough is not on. High speed is doing the other operation. Counter is doing the other operation. Yeah. Everything looks fine to me. So now if you want to increase the parameters, the depth of them, sure, because that's the only thing actually left, or I would say think in parameters just rather than just add like 250 thou in each that you see 1 inch. I mean, it's pretty basic, not for the center drill. Back drill, you can, we have already added that much material, but we are also going to add 0.25 on top of it. Sure. Oh, it's going to be the other way. -1, -1.25. Over that we are going to add this. There we go. Good. Looks good. Then for the pocket as well, we are just going to add, okay, this is fine. 0.25, make sure 0.25 looks good. For this one, we are going to add some material. Add some 25 to 50 thou, and similarly on here as well, 250 thou. I'm pretty sure now this should be good enough for everything that we have encountered with. Shouldn't be an issue. There we go. right here, we are cutting material, we are cutting that right there, and that's high speed. There's a counter. Finish. That's it. So that's pretty much it, guys. So thank you so much for watching, and you will see more and more videos upcoming in future. So stay tuned and do not forget to subscribe my channel. Thank you and take care. Bye bye.